When taking students on extracurricular road trips, the school typically pays $450 to rent a bus using Regal Charter Service. So you know off the top of your head this is not about our school. We have our own buses, right? So this is just a word problem, okay? But is it a realistic word problem? Yeah, not for our school, but it is realistic, okay? However, the school secretary decides to call a competitor to see if the rates are better. Here's what the representative from Fly By Night Rentals had to say. Regal charges a flat fee, but think about the cost per student. With Regal, if only 4 students go on the trip, that's $450 divided by 4, which is $112 per student. In this case, Fly By Night would only charge $78 per student. Think of the savings. But what about large groups? With 54 students, you'd still be paying $450 divided by 54 students, which is $8.33 per student with Regal. With us, 54 students is only $3 per student. Can you believe it? It's all because we're using a linear model to determine the price per student. It just makes sense. Of course, you have to take between 4 and 54 students on the trip, but that's no big deal. So can we count on your business? Like a stalker? Sketchy person? So first of all, let's determine the function rules for each one of these. And then we'll fill in the entries from the table. Okay? Any idea about either Regal or Fly By Night? Which one you want to start with? Regal, okay? So if we look through here with Regal, if 4 students go on the trip, so this is how Regal found out the price for 4 students. And then 54 students with Regal, so this is how they figured out how to do it with 54 students. So how did they figure out their pricing? What is divided by the number of students? So y equals 450 divided by the number of students, which is x, right? Number of students. Okay. So do you want to go ahead and fill in the table now? Okay, so what's 450 divided by 15? 30. You guys didn't even use your calculator for that. I'm so proud of you. What about 450 divided by 30? 15. What about 450 divided by 45? 10. Okay. What about Fly By Night? Let's see. Fly By Night. Oh, okay, so that's important, right? They use a linear model. Oh, well, we should have no problem with it then. If we know it's linear and we have 2 points given to us in the table already, isn't 2 points enough to write the equation of a line? Yeah? How do you do that? Oh, absolutely. That's a perfect way to do it. Yeah, you can do it by hand, right? Find the slope and then put it in point slope form. But we could go to a list and spreadsheet and say this is x and this is y. I don't really know how exactly it did that. Maybe it's magic. I'm going to put them in just in case. Now what? Do you know how to do it from this page? Can I show you how to do it from this page? I know we can add a page and make a data and statistics and identify X and identify Y and then make it add the regression, but can I show you how to do it from this page? Okay, menu. Now I have to remember. Statistics. Stat calculations. X-list is X. Y-list is Y. That's just saying, do you want to save it to the calculator? I'm not worried about that. So it's saying, here's the linear regression, here's M, and here's B. If it's mx plus b, that tells us y equals negative 1.5x plus 84. Does that make sense? It's not as straightforward as the other page, but it's a little bit less keystrokes, I think. Just slightly less. But I didn't know if I had ever shown you how to do it from this page. Okay? Okay so far? So let's fill out the table. What'd you get? $61.50? How are you guys doing this? Are you plugging it in one by one, or are you actually putting the equation in and going to the table? One by one is fine. Yeah, that one by one is fine. Because look, even if you put it in and go to the table, oh, is this how you're going to be? Enter. Oh, seriously. Control T. Look at all the scrolling I have to do to get down to 30. Did you get 39? I know, it's so long to scroll to 45. Okay. But did we all get the same things? Okay. So just remember multiple ways. Okay. Sketch the graphs of these relationships on the grid to the left. I didn't do a very good job with my green one, so I'm sorry about that. Treat these equations like a system and solve it. How do you want to solve this system? That's one option, right? We can do in the calculator and figure out where the points of intersection was. What's another option? I'm sorry, what? Hold on. Absolutely. That's the other way we could do. We could do substitution, right? Since they both equal y, we could set them equal to each other. Yeah, absolutely. Okay? I don't care which way we do it. Which way would you like to do it? It doesn't ask us to do it a particular way. It just says solve it. Calculator would probably take less time. So now I have them both in the calculator, but now I have to fix my window. No, there's no oh no about that. It's okay. First of all, we're given a window as a reference point we can use, right? So for my x-min, I'm just going to use 0, and my x-max, I'm going to use, what do you think? 65, because that's what's on this window, right? On this graph. And my y-min, I'm going to use 0, and my y-max, I'm going to use 120. So when I do my points of intersection, this is 675. So that one's not bad. It's this other one that I messed up on when I drew my graph. Menu, analyze, intersection. So we're just going to use our imagination that I did a better job. Hopefully you did a better job than I did. Because this is supposed to be like back here somewhere. It's not too far off. Just imagine it's somewhere right there. 50 and 9. Okay. What do the solutions tell you about when fly-by-night is a better deal? First of all, when are they the same? When 6 people and 50 people go, the prices are the same, right? So it wants to know when fly-by-night's a better deal. Well, that's my green graph. Okay? What makes it a better deal? It costs less, right? So when is the green line less than the purple curve? Less than 6 or greater than 50, right? But they even tell us in the problem you have to take between 4 and 54 students. So when is fly-by-night a better deal? So 4 and 5, right? It has to be less than 6. Well, the only numbers less than 6 are 4 and 5, right? Does that make sense? Okay. And then is there any other points where it's a better deal? 51, 52, 53, and 54 people. So, is fly-by-night a better deal? I mean what? Depends on how many people you're taking, right? Chances are, because the number of students between 6 and 50 is a whole lot more than just 1, 2, 3, 4, 5, 6. These 6 options, right? But if you are taking 52 students, is fly-by-night a better deal? Yeah, so you kind of need to know how many people you're taking, don't you? Okay. Any questions about this side? We good? Pillows and parachutes. This is one of my favorite problems to teach all year. All year. A parachutist called from her cell phone. Hey, Walter, you'll never guess where I am. I'm parachuting down over your neighborhood. Even though I'm descending at a constant rate of 4.5 feet per second, I'm afraid my landing will be a little rough. So please, can you do me a favor? Go outside and get on your roof. And when you see me, throw me a pillow. Okay? So Walter goes outside and gets on his roof carrying a pillow. And when he sees her, she was 40.6 feet above the ground. He threw the pillow with an initial velocity of 40 feet per second so that its height could be found with this function, this given function right here, where x is time in seconds since the pillow is released. The parachutist missed the pillow when it went up, but caught it on its way back down. So, can you explain to me how many things are wrong with this problem? Guys, first of all, Walter is as tall as his house. Either he's a really tall person or he's living in a really small house. Have you ever seen anyone parachute? They don't float on their stomach. Their feet are falling first.
Yeah, that's why it's going to be rough if you jump face first.
You're gonna throw a pillow 40 feet per second?
Miss Casey, can we look up how fast that is?
No. no, not right now. Not right now. We'll do it later. That's a good point. We should look at it and see exactly how fast that is. And in order for the pillow to be heavy enough, I would think, for you to throw it 40 feet per second, it's not going to do her any good to land on. Okay? Okay, so can we look past the nonsense of this problem and get to the math? Are we okay with that? What linear function can be used to find the parachutist's height in terms of x, which is the number of seconds since Walter threw the pillow? It tells you everything you need to know in the problem. You know this, right? There's a constant rate. So what is that? That's her slope. So y equals, y. Oh, she's decreasing in height, so it is negative 4.8 feet per second. No, so negative 4.8x. And then what? Yep. Y. That's where he saw it, right? And we're assuming we can assume when he saw her, he threw the pillow at her. He only brought one. He knew he would. I mean, she missed it the first time. Treat these two systems as treat these two functions as a system and solve it. How do you want to go about solving this system? Calculator? Okay, that's fine. I'm just gonna add a new page to make it a little bit quicker. So negative 4.8 x plus 40.6. And then I need to get the other equation in there, so I'm going to tab again. Negative 16x squared plus 40x plus 15. Now I can't see anything that I'm going to need, so I need to fix my window. Yeah, if you zoom out a lot, though, it doesn't give you a good perspective. So let's make window settings, but let's think about it. Okay? So what should my x min be? X is the time, right? So what should my x min be? Probably 0, okay? And then what should my x max be? Time. How many seconds are we dealing with here? 60 seconds in a minute. Okay, so let's go with 60. Guys, if any of these are wrong, we can go back and fix them. You know that, right? Okay. What about y min? That's the height, right? So 0. And then how high should it go? So really 40.6, but think about what's happening in the picture. Maybe a little bit higher? How much higher? 45, okay. Is that what we want? No. What do you want to change? Okay, so menu, window, settings. What do you want x max to be? 10? Is that better? It's a little bit better. Are you okay with it? Okay, how are we going to show our work if we're solving it in the calculator? No. We're not going to just write calculator. How are we going to show our work? Draw the graph. Okay. Now we need to solve it. All we did was draw the graph so far, so how do we solve it? Menu, analyze, intersection, right? So this point right here is 0.8, 36.8. And this point right here is 231. Did you get both of those? What do the intersection points mean in the context of the problem? So what happens at this first point? So at 0.8 seconds, she was how high? 36.8 feet off the ground. And what happened right there? She missed the pillow. From that sentence, can you do the second point? Do it. By yourself quietly. And then we'll come back together and make sure you have it all. Is that what you got? At 2 seconds, she was 31 feet off the ground and she caught the pillow? Okay. How much time transpired between when the parachutist missed the pillow and when she caught the pillow? And how did you figure that out? So if you put 1.2 seconds right here, you gonna lose points? Yeah? Why? I don't. At this point, I don't even care if there's a sentence. I just need to see some work. What's the work? 2 minus 0.8 is 1.2 seconds, right? You for sure want a label on your number, 1.2. Definitely don't just put 1.2. But this tells me you know what you're talking about from here to minus here. Does that make sense? If you want to write a sentence, you go right ahead. Especially if you mess up on your math, I can still see that you understand what's going on and give you partial credit. Okay? How much time did the parachutist have to adjust the pillow between when she caught it and when she touched the ground? So I need to figure out when she touched the ground. How am I going to figure out when she touched the ground? What's the... Yeah, y equals 0. So can't I just take this equation right here and put y for 0? Or 0 for y? Okay, let's do that. 0 equals 0.48x, except it's 4.8x, sorry about that, plus 40.6. How am I going to solve that? So you want to subtract 40.6 from both sides? So negative 40.6 equals negative 4.8x. And then? So x equals? $8.46? Is that what you said? Okay. So does that answer the question? What is this? It's seconds, right? And that's when the pillow, when she hits the ground.
So I now have to subtract where she caught the pillow.
So 8.46 minus what? 2, which equals? So she, I don't want to say she, 6.46 seconds had elapsed between, oh geez, I can't spell today, when she caught the pillow and when she landed. Does that make sense? Any questions about that?